This video is going to teach you about valence electrons and Lewis dot diagrams. When you have an electron configuration in shorthand notation, like this one for oxygen, we have the 1s2 tells us that there are 2 electrons, like in this picture, that one and that one, on the first energy level. Then the big sort of coefficient to here and here mean the second energy level, so that would be the second ring right here. And that there are 2 sublevels, the S sublevel and the P sublevel. The S sublevel has 2 electrons in it, P sublevel has 4 electrons in it. But they're all still considered to be on this second energy level. So all of those are the outermost electrons for an oxygen atom. And valence electrons are the ones that are on the outermost energy level. So for oxygen, anything on the second energy level would be a valence electron. There were 2 in the S and 4 in the P, so that's a total of 6 valence electrons for oxygen. If we take a look at calcium, calcium has a lot more energy levels. It has a first energy level, it's filled up the second energy level, it's put 8 electrons on the third energy level. Then we get all the way out to the 4th energy level. It has the S sublevel with 2 electrons in it. This is the highest energy level for a calcium atom, and there are 2 electrons in it, so we would say that it has 2 valence electrons. So here's one that's a little bit trickier. This is arsenic. Arsenic has the first energy level filled and the second energy level filled, and it put the S and the P in the third energy level, but remember that after you fill 3P, then you go to 4s and put 2 electrons there. Then you go back to 3d, which is part of the third energy level, fill it in with 10 electrons, and then come back out to the 4th energy level to start putting electrons in the P sublevel. That means anything on the 4th energy level is on the outermost energy level for arsenic. So we'd have to say this is on the 4th energy level and this is on the 4th energy level. So we have 2 from the S sublevel and 3 from the P sublevel for a total of 5 valence electrons out here on the 4th energy level. So that's how we identify valence electrons. We just look for the largest energy level number and say how many electrons are on that one. So a Lewis dot structure is a way of representing just the valence electrons an atom has. This is going to be really useful when we start looking at bonding. So what we would do for a Lewis dot structure is first count the valence electrons like you just learned how to do, and then a Lewis dot structure has the elements symbol, and then we would use a dot to represent a valence electron. 1 dot for every valence electron. So there's a right way and a wrong way to do it. For pretty much every element, it's wrong to put 2 electron dots on the same side of a symbol before putting 1 on every side. It's similar to Hund's rule, but slightly different. So this would be wrong, to put 2 dots on one side and then only 1 dot on the other side. What we should do instead is spread those dots out with 1 here, and 1 here. So let's look at some examples. Here was oxygen. We had oxygen from the previous slides, and we said that it has 2 plus 4, it has 6 valence electrons. So if I was going to do a dot diagram for oxygen, I would put the symbol for oxygen, which is an O, and I need 6 dots. So I would put 1 here, 1 here, 1 here, and 1 here, 1 on each side, and then go, well, I need 2 more. So I can pick any side I want. I'm going to pick the top, and I'm going to put a second dot there, and then I need to do that 1 more time. So I'm going to pick any side, how about the bottom? And I'll put another dot there. So I have a total of 2, 4, 5, 6. That would be a Lewis dot diagram or dot structure for oxygen. So you have in your packet a periodic table that looks just like this, and there's oxygen. So you could go ahead and put a dot diagram for oxygen just like this on that periodic table. So our next example was calcium. Calcium had 2 valence electrons. So if we were going to do a dot diagram for calcium, we would put the symbol for calcium, and we need 2 dots. Well, we can't put them together, so we just pick any 2 sides. Maybe we put 1 dot here, and maybe we put 1 on top. It really doesn't matter. So we'll go to our periodic table. Here's calcium. Maybe I'll mix it up a little bit and put 1 on each side here. It's still 2 dots, and they're just not on the same side. The last example we did was arsenic, which had 5 valence electrons. So I would put the symbol for arsenic, and I would put 1, 2, 3, 4, and I need one more. I can put it wherever I want. How about putting it on the top? There's my 5 dots for arsenic. So I go back to my periodic table and I put 1, 2, 3, 4, and we'll put that 5th dot right there. Later on, you will have this entire periodic table filled in. You will have a reference of how many valence electrons every single one of these elements has. But for now, we just have these 3. It's a good start.